Welcome to lecture 5 of numerical analysis. In this lecture, I will discuss Lagrange's interpolation formula for unequal intervals. Let y0, y1, y2 yn be the n plus 1 values of the function y equal to fx corresponding to the arguments x0, x1, x2 up to xn, not necessarily equally spaced. It is assumed that the function fx is a polynomial in x. Since n plus 1 values of fx are given, so differences of order n plus 1 are 0 by fundamental theorem of differential calculus. Thus, fx is supposed to be a polynomial of degree n in x. Let Pnx be the polynomial in x of degree n. Then let Pnx is equal to a0 x minus x1 x minus x2 x minus xn plus a1 x minus x0 x minus x2 x minus xn plus a2 x minus x0 x minus x1 x minus x3 x minus xn plus so on. An is x minus x0 x minus x1 x minus x2 x minus n minus 1. Take it as equation 1. And one more thing is to be considered. We see that in the term a0 there is no term containing x minus x0, and if we take a1 there is no term containing x minus x1. We have to consider Pnx like this. So in the note, the term ai occurs has the factor x minus xi lacking. So here a0, a1, a2 an are constants to be determined. We determine the n plus 1 constants a1, a0, a1, a2 an so as to make Pnx0 equal to y0, Pnx1 equal to y1, Pnx2 equal to y2, Pnxn equal to yn. To determine a0, we put x is equal to x0 in equation 1. So equation 1 becomes Pnx0 is equal to a0 x0 minus x1 x0 minus x2 x0 minus xn. So this is the reason behind this, why we haven't take a0 in the term x0. If there is a term x minus x0 here, we don't get any values. So all the terms excepting a0 containing x minus x0, so rest becomes 0 when we put x is equal to x0. Just we left with the terms a0. So since p0 x0 is equal to y0, we are left with y0 equal to a0 x0 minus x1 x0 minus x2 x0 minus xn. So a0 is equal to y0 divided by x0 minus x1 x0 minus x2 x0 minus xn. Similarly, by putting x is equal to x1 in equation 1, rest all the terms becomes 0. We are left with only a1. So from there we will get the value of a1 like a1 is equal to y1 by x1 minus x0 x1 minus x2 xn x1 minus xn. Similarly, by putting x is equal to xn, we will get the value of an like yn divided by xn minus x0 xn minus x1 xn minus xn minus 1. Substituting these values of a's in equation 1, we get Pnx is equal to x minus x1 x minus x2 x minus xn divided by x0 minus x1 x0 minus x2 x0 minus xn y0 plus x minus x0 x minus x2 x minus xn divided by x1 minus x0 x1 minus x2 x2 minus xn y1 plus x minus x0 x minus x1 x minus x3 dot 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 x minus xn divided by x2 minus x0, x2 minus x1, x2 minus x3 dot 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 x2 minus xn y2, and so on. The last term is x minus x0, x minus x1, x minus xn minus 1 divided by xn minus x0, xn minus x1 up to xn minus 1 yn, and give it as equation 2, and this equation 2 is called Lagrange's interpolation formula. Now we will see that how we apply this formula. So let us come to the example. The following table is given. The values of x are 0, 1, 2 and 5. Y equal to fx is 2, 3, 12 and 147. What is the form of function fx? So here we see that the value of x are not equally spaced, as the difference of 0 and 1 is 1, the difference of 1 and 2 is 1, but the difference of 2 and 5 is 3. So values of x are not equally spaced, so we apply Lagrange's formula here. Let x0 equal to 0, x1 equal to 1, x2 equal to 2, x3 equal to 5, y0 equal to 2, y1 is equal to 3, y2 is equal to 12 and y3 equal to 147. Hence, applying Lagrange's formula, we get fx is equal to x minus x1, x minus x2, x minus x3, x0 minus x1, x0 minus x2, x0 minus x3, y0 plus x minus x0, x minus x2, x minus x3, x1 minus x0, x1 minus x2, x1 minus x3, y1 plus x minus x0, x minus x1, x minus x3, x2 minus x0, x2 minus x1, x2 minus x3, y2 plus x minus x0, x minus x1, x minus x2, x3 minus x0, x3 minus x1, x3 minus x2, y3. So substituting the values of x0, x1, x2, x3, y0, y1, y2, y3, we will get x minus x1, x minus x2, x minus x5 divided by 0 minus 1, 0 minus 2, 0 minus 5 into 2, x minus x0, x minus x2, x minus x5, 1 minus 0, 1 minus 2, 1 minus 5 into 3, plus x minus 0, x minus 1, x minus 5 divided by 2 minus 0, 2 minus 1, 2 minus 5 into 12, plus x minus 0, x minus 1, x minus 2 divided by 5 minus 0, 5 minus 1, 5 minus 2 into 147. Simplifying the denominators, we will get x minus 1, x minus 2, x minus 5 divided by minus 1, minus 2, minus 5 into 2, x minus x into x minus 2, x minus 5 divided by 1 into minus 1 into minus 4 into 3, plus x, x minus 1, x minus 5 by 2 into 1 into minus 3 into 12, x into x minus 1, x minus 2 divided by 5 into 4 into 3 into 147. We cannot simplify by simply opening the bracket because it becomes very complicated. So we will simplify it accordingly. We take the terms x, x minus 1, x minus 2 and x minus 5 common from the right hand side. So this further can be written as fx divided by x, x minus 1, x minus 2, x minus 5 is equal to minus 1 by 5x plus 3 by 4 x minus 1 minus 2 by x minus 2 plus 49 divided by 20 into x minus 5. Taking LCM and simplifying, we will get 20x cube plus 20x square minus 20x plus 40 divided by 20x, x minus 1, x minus 2, x minus 5, which further can be written as 20 is common from the numerator, x cube plus x square minus x plus 2 divided by 20, x minus 1, x minus 2, x minus 5. So 20 is cancelled out from numerator and denominator, and x minus 1, x minus 2 and x minus 5 is cancelled out from the left hand side as well as the right hand side. So we are left with fx is equal to x cube plus x square minus x plus 2. This is the required answer. Now this is one more example for practice. Using Lagrange's formula, find the cubic polynomial which includes the following values of x and yx. The values of x are 0, 1, 4, 6, and the values of y are 1, minus 1, 1, minus 1. Using Lagrange's formula, you have to simplify it, and the answer will be Pnx is equal to x cube minus 9x square plus 20x minus 6 divided by minus 6. Thank you.